So today we'll be discussing how we can get to the triple point of water using only basic kitchen equipment and utilities. So we're going to start off with a phase diagram, and we can use this to predict how our water will behave. We have temperature along the x-axis and pressure along the y-axis. So in this region down here, there we go. Obviously water will exist as a vapor. Along here it exists as liquid water, and in this region exists as solid water or ice. Along each of these curves, right here, right here, right here, we can have multiple phases of water at the same time. Our goal is to get to the triple point, which for water is 0.01 degrees Celsius, where all three phases exist at the same time. Now, the main issue with using this phase diagram is that if we start with some sort of vessel, doesn't really matter, it could be a pot, pan, water bottle, anything. We have a little bit of liquid water. We also have a little bit of vapor water coming off the top of the liquid water. The rest of the container is filled with air. So we have liquid water, vapor, and then air. We can't use the phase diagram to predict how our water will behave if there's air in the system. So we have to find a way to remove it. Thankfully for this scenario, it's fairly easy. All you have to do is apply heat to the water. Oh, I'll try that again. There we go. And what this will do is cause more vapor to form, which will cause the pressure inside the vessel to rise, forcing the air up and out of the container. And once we're only left with vapor, all we have to do is seal the container. And now, after boiling the water, we're left with only liquid and vapor air. Or not air, I apologize, water. So now we can use the phase diagram to predict how our water will behave. So right now we're somewhere around here, could be further down, further up, somewhere in this general area of the phase diagram. So we boiled our water, created more vapor. Now to get to the triple point, all we have to do is go back down the axes and get, which means we have to cool it. So now instead of the heat flowing into the vessel, it'll be flowing out. So what do? We chuck it in a freezer. And as we move down this curve, the pressure inside the container will actually decrease, and we will be left with a vacuum. Now, that doesn't mean there's any air in there, it's just empty space because the volume of the container remained the same, but the pressure decreased, therefore there has to exist a vacuum. So as we move down, I'm just going to erase these for the sake of simplicity for now, but we still have a vacuum. It'll keep cooling, and eventually we'll get to around the triple point, at which point ice will begin to form. And actually, it'll be on top of the liquid water. And we'll still have a small amount of vapor in the vessel along with our vacuum. So therefore, we have vapor water, ice, and liquid water all at the same time, with the remainder of the vessel being a vacuum.